Why is it not recording? Hold on, stuff's not attached. All right, so this is just more of what we did yesterday. Just maybe slightly more complex, I don't know. It's just the same thing, but slightly different. So as we look at this, we are factoring quadratic trinomials. So the first thing I want you to do is remember FOIL. So last year, and probably 8th grade, you learned how to FOIL. We called it foiling because that stands for first term. So x times x is x squared. Outside terms, that's the x and the 3, that's plus 3x. Inside terms, hey, and 7 times 3 is plus 21. So it's first terms. We're doing the first terms, then we do the outside, then we do the inside, then we do the last term. That's what FOIL stands for. Just to make sure you multiply everything in the same pattern. So then we combine like terms, and I get x squared plus 10x plus 21. Foiling and factoring, multiplying binomials and factoring are opposite operations. They have the opposite effect. So when I factor this, like we're going to do, I end up with that. And when I multiply, I end up with that. So they're just opposite things. So when we do it again, when we multiply at first term, that's x times x is x squared. Outside terms, 6x minus 4x. Don't forget about your negatives. And negative 24. So it's x squared plus 2x minus 24. So you spent a lot of time last year, probably in 8th grade, reviewing multiplying binomials, foiling, we call it, going back and forth. And so we're just going to take that and go backwards now. So recall that quadratics are polynomials with the highest exponent of 2. So like x squared, t squared, like that. The highest exponent we have is a 2. And trinomials with 3 terms. So anytime I have an expression that has 3 separate terms where the highest one is an x squared, that's called a quadratic trinomial, and I can use this method to factor it and get where I need to be. Last year, you spent a lot of time writing equations and expressions into standard form. We just want to be consistent. And so we do it in decreasing order, where we do x squared and then x and then the constant with no variable. And we just put it in that order so that we're all working the same way as we file through this. Yesterday, we talked about how we make our x puzzles by multiplying a and c and finding those same factors that when we add them gives us b. So we're doing the same thing today. We're going to multiply the numbers in front of the x squared and the constant, and then we're going to make sure that the factors for that number, it can be added to equal b. So it's the same thing. I'm going to look for 2 numbers that multiply here and add here. And I just lost my picture. Where'd it go? All right. So, just like yesterday, the steps for doing this. First, we look for a GCF. If I can divide everything by 2 or 7 or something to make the numbers smaller so they're easier to deal with, we want to do that. You want to use your blue card to find the factors. If you can't do it quickly, this is an easy way to do that. And it's all the way through 100. So it gets almost every number you're going to have will be on this card. When we are trying to solve this, remember the whole point is to find two numbers that multiply to equal AC and then add to be B. I need the same two integers. Then we split that middle term, whatever the B term was, into the answers from step 2, and then we factor by grouping. So it's the same as yesterday, as factoring when x equals 1, except this time the top number is not going to be pulled from the expression as easily. So we label everything A, B, C. It's in descending order. A is 2, B is 5, and C is 3. So when I make my puzzle, that's A times C, that's 2 times 3, which is 6. And then B is 5. So that's 1 times 6 and 2 times 3. When I add my numbers, the two that add to give me 5, 2 times 3 multiply to give me 6, and they add to give me 5. So then I rewrite this middle term, 2x plus 3x. Because 5x is the same as 2x plus 3x. I haven't changed anything. It just looks different. But it's worth the same amount. If I give you 2 quarters or 5 dimes, it's the same thing. So then we rewrite it, 2x squared plus 2x plus 3x plus 3. And now we factor by grouping, meaning that I look at these two terms and I look at these two terms. What can I divide the first set by and the second set by? So the first set I can divide by 2x. And the second set I can divide by 3. So that gives me 2x times x plus 1 plus, and the point of doing this is as I divide this, this should be my second term. I'm trying to force it to be that thing. So then I get 3 times x plus 1. If at any time as I'm dividing through this, these two things aren't the same, then I need to go back and check and see why not, because they should be. Then we take our first and our outside terms and get 2x plus 3. And then our common term becomes our last term at x plus 1. And we're done. So if I were to go back and FOIL this, 2x times x, that's 2x squared. And then I do the outside terms. 2x times 1, that's 2x. 3 times x, that's our 3x, and 3 times 1 is 3. So now I have my original polynomial to check that I've done it correctly. So the only real difference is that as we did this, A wasn't 1. Yesterday A was 1, today A isn't. That's the only difference in everything that we did from yesterday. So as you go through, we label everything, A, B, C. Now it's really important here, so A equals 5. What does B equal? What is B in number 1? It's not 17. So what is it? It's negative 17. The sign in front of the number always goes with it. So that's a really important concept to keep in mind, is you don't want to drop those signs. So A times C, 5 times 6 is 30, and then B is negative 17. Because this is positive, but this is negative, that means that both of my numbers are going to be negative. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. So when I look at that, the numbers that, these are all the factors, all of these multiply to give me 30. But the one that adds to give me negative 17 are negative 2 and negative 15. So we come up here and make that negative 2x minus 15x. So I have 5x squared minus 2x minus 15x plus 6. So what can I divide the first two terms by? I can divide this by x. And I can divide these by negative 3. So then I have x times 5x minus 2 minus 3 times 5x minus 2 to end up with x minus 3, my outside terms, and then my one common term, 5x minus 2. It really is the same thing as yesterday. All right, so as we look at number 2, when I multiply AC, that's 6 times negative 4. That's negative 24. And B is negative 5. So as I list my factors, because this is a negative number, that means one of my factors is negative. And because my addition is negative, that means that the larger set of numbers will be negative. And since I always write my small numbers here and my big numbers here, that makes it easy to figure out. So that is 1 times negative 24, 2 times negative 12, 3 times negative 8, and 4 times negative 6. All of those multiply to be this top number. So now I just have to figure out that this is the set that when I add will give me negative 5. So I'm going to rewrite plus 3x minus 8x. So I have 6x squared plus 3x minus 8x minus 4. I can divide this by 3x and this by negative 4. 3x is 2x plus 1 minus 4 times 2x plus 1. 3x minus 4, 2x plus 1. So you can see that we're just taking all the steps that we've done. The factoring by grouping, excuse me, the X puzzle that we did. It's just all the steps that we've done up to this point to get to this process. When we look at number 3, we do our X puzzle. 12 times negative 5, so we have negative 60, and it needs to add to be 11. So if you don't, just go ahead and look at the factor chart. If you make yours, I want you to pay attention to how I process my factors. I start over here with the small number 1 and whatever it is, times 60. And 2 times 30. And 3 times 20. And 4 times 15. 5 times 12. 6 times 10. And then I'm done because 7, 8, and 9, which are between these two, don't go into that. So that's why my small numbers are always on this side and the larger numbers are over here. Now I multiply to get a negative answer. That means I have one positive and one negative. And because my addition answer is positive, that means the larger number has to be positive, and these all have to be negative. So as I do that, the one that adds to be 11, is negative 4 plus 15, gives me 11. So then I rewrite negative 4x plus 15x so that I get 12x squared minus 4x plus 15x minus 5. I can divide my first term by 4x, first two terms by 4x, and my second two terms by 5. 4x, 3x minus 1, plus 5 times 3x minus 1, 4x plus 5, 3x minus 1. If you follow the process and just do the same steps over and over again, it becomes easier and more of a pattern that you can follow through. What happens when I have big numbers like this? It's better to get rid of the GCF just so that I have numbers that are more manageable. I can do them easier in my head. So what can I divide 10, 75, and 35 by? I can't divide it by 2 because 35 and 75 don't divide by 2, so it has to be 5. So my GCF is 5. So that becomes 5 times 2x squared plus 15x plus 7. And then we say that this needs to be 2 times 7, which is 14. And it needs to add to be 15. So that's 1, 14, 2, and 7. The ones that multiply are those, or add, are those. So I rewrite this as 1x plus 14x. So I get 2x squared plus x plus 14x plus 7. I'm going to divide these by x and these by 7. X times 2x plus 1 plus 7 times 2x plus 1. Now don't forget about this 5, because that becomes 5 times x plus 7, 2x plus 1. And that's our final answer. So as you factor out that first GCF, make sure that you don't forget it when you get to your final answer. So for this one, I can divide everything by 2. So my GCF is 2. And so that leaves me with 6x squared plus x minus 1. So when I multiply, I get 6 times negative 1 is negative 6, and my middle term is positive 1. So when I list my factors, 1, 6, and 2, 3, one of them needs to be negative, and it has to be the smaller one because my answer is positive. So when I look at this, negative 2 plus 3, when I add, gives me positive 1. So I'm going to rewrite this as negative 2x plus 3x. So I have 6x squared minus 2x plus 3x minus 1. Don't forget that this 2 needs to come back here. Maybe do an arrow like that as you're working so that you remember to bring it down. So I can divide these by 2x. Now, I need to divide this by something. What can I divide 3x and 1 by? 1. I need to divide it by something. I have to have a second term. So I can, if I can't divide it by anything else, I can divide by 1. So that gives me 2x times 3x minus 1 plus 1 times 3x minus 1. So then I have my arrow. That means I bring the 2 down from above, and then I get 2x plus 1, 3x minus 1. And there's our final answer. So little tricks like drawing an arrow to remember to bring that down. Remembering how your signs work, that I need a negative here but a positive here. So that means the bigger numbers have to be positive. Always following in the same order where you put the small number here and the bigger factor on the right. Things like that will help you be successful if you do them the same way over and over again. All right, so here. I'm just going to do part of the problem here. So your GCF for this is 3. So that gives me 3 times 5x squared minus 6x minus 8. And when I multiply, the top number is 5 times negative 8, which is negative 40. And my addition number is negative 6. And don't forget to bring that one down when we're done. And as we do the next one, same thing. The GCF here, it's not super big, but I still want to do it. My GCF is 2. So that gives me 2 times 16x squared minus 8x plus 1. And when I do the x puzzle, that's 16 times 1. Which is 16, but then I end up with negative 8 down here. So I want to figure out what my answers are going to be to end up with a positive 16 but a negative 8. And don't forget to bring that 2 down when we're all done.